speaks truth is 4 by 5, while this probability for B is 3 by 4, the probability that they contradict each other when asked to speak on a fact is going to be. The first option is 4 by 5, the second option is 1 by 5, the third option is 7 by 20, and the fourth option is 3 by 20. So first we need to understand the question. Probability that A speaks truth is 4 by 5. So let's write it down. P of A speaking truth is going to be 4 by 5. That means 1 out of 5 times he is known to speak a lie. So that is nothing but P of A bar, which would be 1 minus 4 by 5, which is 1 by 5. And similarly, the probability that B speaks the truth is 3 by 4. And the probability that B does not speak the truth is going to be 1 minus 3 by 4, which is 1 by 4. Now the question is, find the probability that they contradict each other when asked to speak on a particular fact is. What is the meaning of the word contradict? The meaning of the word contradict is that when A speaks truth, B is speaking a lie. Or B speaks truth, A is speaking a lie. That is when they will contradict each other, oppose each other while they speak on the same fact. So that simply means the required probability is probability that A speaks the truth and B does not speak the truth. Probability that A speaks the truth and B does not speak the truth. We have discussed that AND represents intersection in probability. Or A speaks a lie and B speaks the truth. Now here two ideas we are going to apply. First idea is that our understanding that these two events are going to be mutually exclusive. That means both of them cannot occur simultaneously. So I can write this as P of A intersection B bar plus P of A bar intersection B. That's the first step. Now the next thing is, let's go into P of A intersection B bar. That means probability of A speaking the truth and B not speaking the truth. Now these two events are totally independent, right? So that means P of A intersection B bar is simply going to be P of A into P of B bar. Similarly, P of A bar intersection B bar is going to be P of A bar into P of B. Therefore, P of A, that means probability that A speaks the truth, which is 4 by 5, and B does not speak the truth, that means 1 by 4, plus A does not speak the truth, which is 1 by 5, and B speaks the truth, which is 3 by 4. So 4 by 20 plus 3 by 20, which simplifies to 7 divided by 20. Therefore, the right answer for this particular question is the third option. Dear students, now we are going to discuss another interesting question from probability. 3 mangoes and 3 apples are in a box. If 2 fruits are chosen at random, what is the probability that one of them is a mango and the other is an apple? Now we understand there is a box in which there are 3 mangoes and 3 apples. Totally there are 6 fruits. Now we are taking 2 fruits one after another and they are chosen at random. What is the probability that one is mango and the other is apple? Now here we have to be a little careful, students, in avoiding a particular common mistake. The common mistake is students take probability of finding or obtaining the first fruit as mango, which will be 3 divided by 6. Now we have taken one of the fruits, so the total number of fruits becomes 5. And next we are going to draw an apple. How many apples do we have? There are 3 apples. And total number of fruits now is 5 because we have already taken one mango. So the probability of taking an apple now, given that a mango has already been taken, would be 3 divided by 5. And students may stop right there. But we must understand that there is nothing mentioned about the first is mango, second is apple. Have they mentioned something like that? No. It is only mentioned that one of them is mango and the other is apple. So there are 2 possibilities. First possibility is first is mango, second is apple, or first is apple, second is mango. Now let us understand the required probability. So the required probability would be first case, first is mango and the second is apple. So first fruit being mango, what is the probability? The number of favorable outcomes divided by total number of outcomes, which is 3 divided by 6, and multiplication theorem. Now we are drawing apple. How many apples are there? 3 apples. Total number of fruits now is 5. Therefore, it would be 3 divided by 5. Or this would have been one of the possibilities. Whenever I say or, I understand it should be a plus here because they are mutually exclusive events. Now, first is apple now. First fruit being apple, what is the probability? 3 divided by 6. And now the second one is mango, which is going to be 3 divided by 5. Or in other words, 2 times of 3 divided by 6 into 3 divided by 5. So I can do some cancellations here. So this would be 2 and this will also be 2. So 3 by 10 plus 3 by 10, that would be 6 divided by 10, or I can write it as 3 divided by 5. Therefore, the right answer for this question is going to be the second option, which is 3 divided by 5. Dear students, now let us look into the next question in probability. A card is drawn at random from a well shuffled pack of 52 cards. Then the probability that the card is neither a red card nor a queen is going to be. So we already have some idea regarding the cards. A pack of cards has 52 in number, and out of which you have 26 of that which are going to be red and 26 are going to be black. And how many queens are going to be there in the pack of 52 cards? We have 4 queens. How many of those queens are going to be red cards? 2 of them. How many of them are going to be black cards? 2 of them. Now let us put all these things into statements here. So let R represents the probability or the event that we are drawing a red card. Then the probability of that event, P of R. The probability that the drawn card is a red is going to be 26 divided by 52, which is 1 upon 2. And then the probability that the drawn card is going to be a queen is going to be 4 divided by 52. And the probability that the card is a queen and it is also a red card, that means probability of the card being red and the card being queen would be. So we have 2 red queen cards, therefore it's going to be 2 divided by 52. So what is that we want? Probability that the card is neither a red card nor a queen. When I say neither a red card nor a queen, that means it should not be red card and it should not be queen. So how do we write that? neither red card, that means not a red card bar. And whenever I have told you that whenever there is an and in the logical question, it's going to be intersection. So P of R bar intersection Q bar, which means it's neither a red card nor a queen. Now we have to apply what we have learnt in sets, De Morgan's law. What is P of A dash intersection B dash? P of A union B the whole dash. So that would be probability of R union Q the whole dash. And which is going to be nothing but 1 minus P of R union Q. And we know the formula for P of R union Q, which is going to be P of R plus P of Q minus P of R intersection Q. So this would be 1 minus P of R. What is P of R? 26 by 52 plus P of Q. P of Q is 4 by 52 minus P of R intersection Q, which is 2 divided by 52. So we have 26 plus 4, 30, 30 minus 2, that's 28. So we have 28 divided by 52, 1 minus 28 divided by 52. Now in case I am going to divide this by 4, this would become 1 minus 7 divided by 13. Now we take LCM, 13 minus 7 divided by 13. So 13 minus 7 is going to be 6. So 6 divided by 13 is the right answer, which is the first option. Dear students, we are now going to discuss a very interesting question from probability. Let's look at the question here. A pack of playing cards was found to contain only 51 cards. If the first 13 cards drawn are all red, then the probability that the missing card is black is. If you analyze this question, this is a problem from Theorem on total probability and Bayes theorem. So what would be the approach that we would take in 12th standard to solve the sum? And we are not going to take the same approach in the competitive exam preparation now. However, I will discuss this question for you first. So we know that the total number of playing cards in a deck is going to be 52, and out of which 26 are going to be red and 26 are going to be black. Now what is that we are doing here? We are going to draw 13 cards. And all the 13 cards are found to be red. Now what is the probability that the missing card was black? That means normally 52 cards would be there, but then one card is missing. So that means we only have 51 cards. And after that we are picking up 13 cards and all of them are red. Now what is the probability that the missing card would have been black? Now here how Bayes theorem is applied, let's look at it step by step. The first thing is, the missing card could have been black or red. So two options are there right with us. If the missing card had been black and then we are drawing 13 red cards, then the respective probability would be 1 by 2 multiplied by probability of selecting 13 red cards, which would be nothing but 26C13 divided by 52C13. Why is it so? Because we have 26 red cards and out of which we had drawn 13 red cards. So it's the probability, the number of favorable outcomes is going to be 26C13. And in the denominator normally we would have 52C13 had we, if we had all the 52 cards in place, but because now we have 51 cards, it's going to be 51C13. And why is that 1 by 2 for? The 1 by 2 is the probability that the red card was lost, because either the red card could have been lost or the black card could have been lost, each carrying a probability of half. because there are 26 red cards and 26 black cards. Now this is one probability that the lost card is red and we are picking out red cards, 13 red cards. Or the other possibility is the lost card is black and then we are picking out 13 red cards. Now I am going to write this for you. So probability that we are picking up 13 red cards. So two chances. One is that the black card is lost or the red card is lost, and both are mutually exclusive events, which means the occurrence of one is going to prevent the other. So we have this probability. So first the black card is lost, let us say, then the probability is 1 by 2, and that means we have to use multiplication theorem. Black card was lost and we are now picking 13 red cards. So probability of picking 13 red cards is going to be 26C13 divided by 51C13. So what is the reason for this? I go through this again. Half is for black card being lost and we are picking up 13 red cards. Now how many red cards do we have? 26 red cards and 25 black cards, because one black card is already lost. Or because it's mutually exclusive, or becomes union and union becomes plus. Probability that we have lost a red card now. So red card, the probability of losing it is 1 by 2, and now we are picking 13 red cards. How many red cards do we have now, children? Totally 52 were there. Now one card is lost, which means totally we have 51. But now red card is lost. That means the total number of red cards which is with us is not 26, but it is 25. So out of that 25, we are picking 13. Therefore, the total number of possible cases is 25C13 divided by the total possibilities is 51C13. So now this is theorem on total probability. That means we have drawn 13 red cards. Now this question is not only theorem on total probability, but it is Bayes' theorem. Let's go over to the question again. Given that 13 red cards are red, then what is the probability that the missing card is black? So this means it is from Bayes' theorem. So given that 13 cards drawn have been red, then black card is missing is nothing but the total number which we got here. We are going to write it 1 by 2 into 26C13 divided by 51C13 plus 1 by 2 into 25C13 divided by 51C13. And what do we place it in the numerator? The first portion here is for the black card to be lost, and the second portion here is for the red card to be lost. So here the question is, given that the 13 cards drawn are red, what is the probability that it is black card which was lost? So the first part comes to the numerator. So it's going to be 1 by 2 multiplied by 26C13 divided by 51C13. Now we simplify this expression and obtain the answer. Now this is what exactly we do in 2nd PUC or 12th standard. But I recommend you to follow another logical approach to getting the answer for this sum. Obviously, because this simplification is going to take more than 3 to 4 minutes, it may not be worth your time. So we will need to discover an alternate technique by which we can quickly approach the sum. Now consider, children, let's do the same sum by an alternate approach, by a simple logical approach, for which we need no formulae, no calculation. Simple mental arithmetic. We have 52 cards in general. Now I am taking 13 cards out of it, and all of them are red. That means 13 red cards are gone. So how many cards do we have remaining? 39 are there. 52 minus 13, 39 cards are remaining with us. Now tell me, children, totally 52 cards are there. Let's not consider the missing card right now. 52 cards are there, out of which I have drawn 13 cards, and all of those 13 cards are red. Now we have 39 cards which are remaining. In that 39, just can we understand how many cards are red and how many cards are black? Yes. 26 cards are black because they are intact. And we have 13 red cards because out of the 26, already we have drawn 13 red cards. I hope you are able to visualize this situation. So 13 red cards have been removed already. So 26 black cards and 13 red cards are remaining in the deck. So now let us focus on what is remaining in the deck. So we have 13 red cards and 26 black cards. Now let us simply understand what is the probability of losing a card now. If we are losing a red card, then the probability is going to be 13 divided by 39. That's 1 by 3. If the probability that we have to find is that of a black card being lost, then it is how many black cards do we have left? 26. And how many total cards are there? 39 right now. So 26 divided by 39, which works out to 2 divided by 3. The same number 2 divided by 3 we are going to get when we apply Bayes' theorem also. I request you or recommend you to simplify this so that we get 2 divided by 3. But I recommend whenever you are answering a competitive exam to think logically and get the answer within a minute. So the right answer for this question is going to be 2 divided by 3. Dear student, now we are going to discuss another question from the chapter on probability. A problem of mathematics is given to 3 students whose chances of solving the problem are 1 by 3, 1 by 4 and 1 by 5 respectively. The probability that the question is solved is, the options are 2 by 3, 3 by 4, 4 by 5 and 3 by 5. This has been asked in a national level competitive entrance exam. Very simple question. A problem in mathematics is given to 3 students and their chance of solving are 1 by 3, 1 by 4 and 1 by 5. Let's consider the 3 students to be A, B and C. Probability that A solves the problem is 1 by 3, which implies the probability that he does not solve the problem is 2 by 3, 1 minus 1 by 3. We know that P of A bar is 1 minus P of A, so that makes it 1 minus 1 by 3, which is 2 by 3. Similarly, P of B is given to be 1 upon 4. That would naturally mean P of B bar is going to be 1 minus 1 by 4, which is 3 by 4. And probability that C solves the problem is 1 by 5. That means probability that C does not solve the problem is 1 minus 4 by 5, 1 minus 1 by 5, which is 4 by 5. Now there are again 2 approaches to solving this problem. Usually in 12th standard, the approach that we take is, first we understand the question, the probability that the question is solved. What do we want? We want the question to be solved, which means we are not bothered who is solving the problem. Whether A solves it or B solves it or C solves it is not a concern. The problem must be solved. So what is that quantity which we need to find? We need to find P of A or B or C, which is nothing but P of A union B union C. So we are interested in finding P of A union B union C. Because union represents OR, we are just interested in getting the problem solved. We are not bothered with who is going to solve it. So that means it is P of A or B or C, which is P of A union B union C. Now the usual step that we do in our board examination is P of A union B union C. We know the formula, which is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. So we write the whole thing. Then P of A, P of B, P of C values we substitute. Then P of A intersection B, B intersection C, C intersection A. We must apply a concept called independent events. We assume that the students are not discussing while they are solving, they are writing it like a test. That means they are independently solving the questions, which means P of A intersection B is going to be P of A into P of B. P of B intersection C is P of B into P of C. P of C intersection A similarly is P of C into P of A. And finally, P of A intersection B intersection C would be also P of A into P of B into P of C. We do all those computations, simplify taking LCM and finally get our answer. This is one approach. But there are chances that we take more time. At the same time, we may have to spend, we have to be very careful in taking LCM and simplifying, right? So what is the other approach that we could use? De Morgan's law. We know that A union B whole dash is A dash intersection B dash. Similarly, if we see here, what is A union B union C the whole bar? That's going to be 1 minus P of A dash intersection B dash intersection C dash. That's going to be the formula. Or what is the logic behind this? Very simple. Instead of finding all the possible cases in which the sum would have been solved, we are finding exactly the opposite. What is the opposite? The problem is not solved. When will the problem not be solved? When A does not solve it, and B does not solve it, and C also does not solve it, then the problem is not solved. So we find exactly the opposite of what we want first, and then subtract that quantity from the overall probability of 1. So probability of occurrence or a success is going to be 1, or in other words, probability of a certain event is 1. So P of A plus P of A bar is 1, so P of A would be nothing but 1 minus P of A bar. Same logic we are going to apply. So what is the logic once again? We want the problem to be solved, but that we are finding it through another way, which is 1 minus probability of the question is not solved. So which is nothing but 1 minus P of A does not solve the problem, which means A bar, and B also does not solve the problem, which means intersection B bar, and C also does not solve the problem, which is intersection C bar. Now last step here, 1 minus P of A bar intersection B bar intersection C bar is going to be P of A bar into P of B bar into P of C bar, because A, B and C are independent events. Then A bar, B bar, C bar are also independent events, which you must have learned from theorem in multiplication theorem. Under multiplication theorem, you have a solid example which says if A and B are independent, then A bar and B bar are also independent. So therefore, A bar and B bar, C bar being independent, P of A bar intersection B bar intersection C bar becomes P of A bar into P of B bar into P of C bar. We have already computed those values, so it's going to be nothing but P of A bar, which is 2 by 3, P of B bar, which is 3 by 4, P of C bar, which is 4 by 5. You can see that all these things cancel here, 3 and 3 cancel, 4 and 4 cancel, we get 2 divided by 5. 1 minus 2 divided by 5 is the right answer, which is 3 divided by 5. So the right option for this question is the fourth one, which is 3 by 5. Dear students, it has been a great pleasure interacting with you in the chapter of probability. In fact, with respect to CET, we have about 4 to 5 questions coming from this chapter every year. I recommend you to pay keen focus on each of the topics that were covered in probability and practice a lot of questions, so that with every effort that you are taking, you are going to increase your probability of success. In fact, my wish and prayer is that you increase your probability of success to that and such an extent that it becomes a certain event. Probability of your success, let it be 100%, or the probability of success is 1. Thank you very much. I wish you all the best once again. This is your Prasanna Kannan.